All right, the standard deviation. Standard deviation describes the spread of the data, whether it's wide or whether it's all close together. So standard deviation tells you how spread out things are. It can be really spread out or it can be really close together. Okay? All right. The more widely spread something is, so the more wide it is, would you guess the standard deviation would be bigger or smaller if it's more wide? Bigger. Okay, that'd be a logical place to guess. All right, it'd be bigger. The less spread out it is, so if it's really close together, do we think the standard deviation is going to be bigger or smaller? Smaller. Okay. All right, so the standard deviation tells you the spread. It also tells you the variability. How do you spell this? V-A-R-I-A-B-I-L-I-T-Y. I'm not a very good speller. The standard deviation also tells you the variability. That's variety. All right, what does it mean if something has a lot of variety? You have a lot of different choices, right? So variety, okay, how different it is. It could be the same or it could be very different, okay? If the standard deviation is smaller, do you think there's going to be more or less variability? If it's smaller, less, okay, there's going to be less variability. If the standard deviation is larger, do you think it's going to have more or less variability? More, okay? And we'll talk about that more with an actual example, okay? All right. So this is called a normal distribution, all right? You'll see those if you take AP Stats or if you go to college. You might have to take a stats course in college. So a normal distribution, this is actually really interesting. If you took everybody, you have to take like a really large sample, a really large population. So if, let's say you took everybody in America and you measured their heights and you plotted them on a graph, it would look like this. Most people are average. You've got some people who are really tall, like 7 foot, and you've got some people who are really short, like 4 feet tall. Okay? So this is just what happens. If you took everyone's shoe size, the same thing would happen. All right? So you get normal distribution of the data. Okay? And the average falls in the middle on a normal distribution. All right, so let's talk about that more with an actual example. All right, so look at the following distributions and answer the questions. Okay, so this question 1, what is the mean? What is mean? The average of graph A. So this is different than a box and whiskers. We did box and whiskers yesterday. Was mean on a box and whiskers? No, on a box and whiskers there was minimum. What else was on a box and whiskers? Q1, Q2, Q3, and the max. On a normal distribution, so this is a different graph, the mean is in the middle. So right here, that's the mean. All right, so of graph A, what would we guess it is? 40. Okay. All right. Chase, what would you... For number 2, it says the mean of graph B. What would you say to that? Good. Graph B is at 30. Okay. All right. This next question. Which graph has a larger standard deviation? Standard deviation tells you the spread. So they both start with an S. Standard deviation is the spread. Which one is more spread out? A or B? B, sorry, and this one should have a B right there. So B has the larger standard deviation. It's more spread out. Okay. All right, let's talk about this. What would happen to the mean? What is the mean? The average of graph B if we added the number 30. If we added another person who, let's say, what would be something that's 30? Has 30, what's something you would have 30 of? All right. Yes, we're seeing how much money people have in their wallet. So let's say we add somebody who has $30 in their wallet to the mix. What happens to the average of this graph if we add somebody who has $30 to it? What would you guess would happen? All right, what is the average of this one? 30. If we add another person who has 30, does that change the average? No, it doesn't change the average. Nothing would happen if we added 30. Nothing would happen to that. Okay? I guess I could put NA. That'd be a good abbreviation. Okay? The average is already 30. If you add someone who has 30, it doesn't change the average. Okay? Now, if I add somebody who has $20 in their wallet, if I add another person who has 20, what happens to the average? It's going to go down. The average was at 30. If I add a 20, it's going to go down. Okay? Faith, what do you think will happen if I add somebody who has $48? What do you think will happen to the average? It will go up because the average was 30 and you're adding somebody who has more. LeVar, what do you think if I add somebody who has 12? It would make it go down because that's less than the average. Okay? All right, the next question, what would happen to the standard deviation? Samaria, what did we say standard deviation means? This, how spread out it is. Okay, so if we add someone who has $30, Jack, is that going to change how spread out this is if I add a 30? No. All right, so again, nothing happens to the spread. Faith, what if I add somebody who has 32? So that one's kind of tricky. What do you think? If you add somebody who has $32. Yeah, so this one you could kind of argue either way. It would go up a tiny, tiny bit. Overall, in the big scheme of things, nothing would really happen. But you could say it would go up. It would spread out just a little bit. It would spread out a tiny bit. Okay? All right, Hallie, what if we add somebody who has $47? What happens then? It would definitely spread out. It would definitely spread out. Okay, here's the real kicker, okay? If I add somebody who has $15, what does standard deviation tell you again? The spread. If I add somebody who has 15, does it get more spread or less spread? It becomes more spread. So even though 15 is a small number, the spread still gets higher because I'm spreading it out. I'm spreading it out. Okay? All right. Zach. 6 says what would happen to the range. Zach, what's the formula for range? Good. Maximum minus minimum. All right, so let's talk about what the range of graph B is before we talk about adding any numbers. Stephen A., what's the maximum of graph B? No, all the way to the end. What's the maximum? 50. Okay. And Riley M., what's the minimum? 10. So Chase, what's 50 minus 10? Okay, so that's the range of the graph right there. So you have to be careful. If we add 30 to this graph, will 30 affect the range at all? What's the only way to affect the range? To add a smaller number or to add a bigger number? The only way to change the range is to change the maximum number or the minimum number. So 30 doesn't change it at all. 30 doesn't change it at all. Madison, what do you think about 15? Would that change it? So how do we get range? What do we do? And max minus min. So if I put in 15, does it change the maximum? Does it change the minimum? All right, what is the minimum? Is 15 smaller than 10? No, so it doesn't change it at all. Okay? Jeremy, what about 49? Would 49 change it? No. Good. All right, Elijah, would 55 change the range? Why? Very good. It's higher than the maximum, so it would be your new maximum. What would happen to the range? Would it go up or go down? It would go up. Look, if I do 55 minus 10, what's 55 minus 10? 45. It goes up. Okay? Check here. If I add a 6 to the mix, does that change the maximum or the minimum? Yes. Guys, look what happens. If the minimum is now 6, what's 50 minus 6? 44. What happened to the range? It went up. All right, the range got larger. The range got larger. All right, so these are ones you have to think through them. They're thinking problems. Okay. All right, Kyle's test scores are as follows. If Kyle makes a 98 on his next test, which of the following would be true? Okay. All right. A says the mean decreases. Riley K, how do we find the mean? Good. You find the average. How do you find the average? Good. Since we're also going to have to find these other things, let's, instead of doing it, add them all up and divide, what else can we do, guys? Let's do that. Let's put them in stats. So everybody do that now. So enter, enter, enter. All right. Elijah, what is the calculator? Which one of these numbers is the mean? Good. The X with the bar over it. All right, X bar. So 89 point, what was it, 9? Okay. That was the average. If Kyle makes a 98 on his next test, will that make the average go up or go down? It'll make it go up because it's a higher number. It'll make it go up. So this says the mean decreases. Is that true? No. Okay. All right. B. LeVar, how do I get the range? All right. So in the calculator, remember it'll give that to you. So scroll down in your calculator. Zach, what's the calculator say the maximum is? Jack, what's the calculator say the minimum is? All right, so somebody tell me what 103 minus 76 is. What? Okay, so guys, you've got to think. If I add 98 into this list of numbers, does 98 change the maximum? Does 98 change the minimum? No. So would the range increase? No, the range would actually stay the same. So it can't be B. All right. In your calculator for standard deviation, that is the SX. So you can see it right there. SX is the standard deviation. So you get 8.02 is the standard deviation. All right, what I want to do, we can kind of talk about it, but I also want to get an exact answer. So the average was 89. The average was 89. If you add 98 to the list, do you think the spread is going to get larger or smaller if you add 98 to it? What do you think is going to happen? It's probably going to get larger. So I would say C is not an answer. But let's test that. So go to your calculator and go back to stat and then go back to edit. And all you have to do is go to the bottom of your list. Oops, be careful. So do this with me, please. Go to the bottom of your list and let's add in what he would make on his next test. Let's add in the 98 and press enter. So this doesn't take very long and it's a good check. Then I want to press stat, go back to calc. What is your new standard deviation? 7.98. So it did decrease. So our intuition was wrong on that. All right. So the standard deviation is now 7.9.
How does that work? Why did it decrease?
I don't know. Let's talk about it first. All right. So this one says Miss Patterson's bowling scores for the past month are the following. If she scores the following on her games this weekend, what could be said about the data? Okay, so this one talks about less peaked and more peaked. The calculator doesn't give you a number for peak, all right? So this is one you actually do. You have to draw this one out. So this will maybe make a little more sense when we do this one. So let's put these in order. We're just going to put these in order. So write these down on your paper. All right, so what's the smallest one? 170, okay? What's the next one? Okay, now what I want you to do after you have them in order, I want you to take her new scores. I want you to take her new scores. So 241, and we're going to put it in the right place, and we're going to circle it so we know it's a new score. So add 241 to the end and circle or underline it so you know it's a new score. All right, 198 would go right here. So just squeeze it in and circle it. All right, what about 162? Where would that go? And circle it so you know it's a new one. And then 230 would go here. Okay, so let's talk about the easy part first. Did it become more spread or less spread? Let's talk about that first. Did I add anything to the ends? Did I add anything to the ends? Yes. So that spreads it out. Okay? If I put all of you in a line and then I add more people to the line, that's going to spread the line out. So it became more spread. Do we agree with that? All right. That makes sense to me. More spread. So we can mark out C and D. Okay? It became more spread. I added things to the end. Now the peak is going to be in the middle. Think about a mountain peak. Okay, the peak of a mountain is in the middle. Did we add anything in the middle? Yes, so we also make it more peaked. We also added stuff to the top of the mountain. So it became more peaked as well. So we added stuff to the ends. We spreaded it out. That's not a word. And then we added stuff to the middle to make it more peak. Okay? All right. Here, we've got two curves. I know these are really hard to see, but it's kind of hard to see on your paper too, but let's go with it. All right. A says normal distribution 1 has the higher mean and standard deviation. So this is 1, and this is 2. Where are the means on these pictures? Where are the means? Yep, in the middle. All right, they are in the middle. So on 1, where's the mean? Where is it? At 5, good. And where is it on 2? At 7. So which one has the higher mean? Yeah, so 2 has the higher mean. 2 has the higher mean. So A says 1 has the higher mean, so we can mark that out. C also says normal distribution 1 has the higher mean, so we can mark that one out. So we're narrowed it down to B and D. All right, now let's talk about the standard deviation. The standard deviation, what's the other word for that? Spread, how spread out it is. Which one's more spread out? 1. So 1 is more spread, which means it has a higher standard deviation. It has a higher standard deviation. So what answer choice says that? D. All right. Which set of data would you expect to have the greatest standard deviation? Chase, what did we say standard deviation is? Good. So we want one that has the greatest spread. Which one has the greatest spread? All right. A says the heights in centimeters of all students in the first grade classes in a large elementary school. B says the heights in centimeters of all first grade teachers. C, the heights in centimeters of all first grade students and all first grade teachers. D, the circumference in wrist for all the students in your class. Or E, the foot lengths in centimeters for all the teachers in your school. Okay, so those are all of our answer choices. Stephen A., if I take the heights of all students in first grade classes, should those heights be pretty similar? Yes. Okay, so that one's not going to have the greatest spread, so I can mark out A. Riley M., B, the heights of first grade teachers, are those going to be pretty similar? Yes, so that one's not going to have a high standard deviation. Shakira, C says, I'm taking first grade students and first grade teachers. Are they going to have similar heights? Think about this. This is a first grader, and this is their teacher. Are they going to have similar heights? No. So if we wrote down all the heights of the first graders and all the heights of the teachers, would they be spread out, the heights? Yes. So C is your answer on that one. Okay. With me? All right. This one, which manufacturer has the least variability in their bricks? Which one has the least variability? Riley K., which one do you guess, hypothesize, has the least variability? Last one, Daniels Bricks. Why is it Daniels Bricks, guys? Because it's the closest together, all right? Least variability. It's very close together. All right. The table below shows the population of several cities. What would happen to the data set of Tinkerton with a population of 50,000 was added to the data? Okay, so let's just go ahead and, guys, if you'll extend this, draw some lines out, and we're going to write down the numbers that we get from here, and then we're going to write down numbers when we add 50,000. So just do this. I'll explain what I mean more in a minute. I know this is confusing right now, but just draw your lines out. And we're going to make a little chart. Okay, we are going to put these in stat, and we're not putting in the 50,000 right now. So we're just putting these in stat, not the 50,000. So you're putting in 1, 2, 3, 4, 5, 6, 7 numbers in stat. Putting in 7 numbers. All right, Faith, what are you getting for the standard deviation? Say it again. 909. Like that? 12,309. Oh, yeah, like this. Like that, right? Okay. Jeremy, what is the formula for interquartile range? Learned it yesterday. What's the formula for IQR? Madison, what's the formula for IQR? Good. Q3 minus Q1. I may have to do that down here. So, Mary, what you got for Q3? All right, what you got for Q1? All right, so Mary, what's 30,000 minus 15,000? So the IQR is 15,000. Q3 minus Q1. Okay. Hallie, how do you get the range? Good. Max minus min. Madison, what is the maximum? Shakira, what's the minimum? What is it? Okay. Riley K, what's 40,000 minus 500? Just 500, so it's 39,500. Okay. And Riley M, what is the mean? X with the bar over it. Chase, show her the mean on the calculator. Okay, so we wrote them all down. This will give us the exact answer. Now go back to stat, add 50,000 to the bottom of your list. Go back to stat, add 50,000 to the bottom of your list. All right, Stephen A., what's your new standard deviation? Say it again. SX, right there, SX. 15112. Stephen A., did it decrease? No. LeVar, what's the formula for interquartile range? All right, what's the Q3 and Q1, LeVar? 35,000 and 18,000? All right, what do you get when you subtract those? Elijah, did it decrease? No. Elijah, how do you get range? Max minus min. Samaria, what's your new max? What's your new maximum? Scroll down. 50,000. Jeremy, what's your new minimum? $500. Zach, what do you get when you subtract 50,000 and 500? All right, did it decrease, Zach? No, so it has to be D. And Jack, what's your new mean? Okay, so it did increase. So D is the answer. Okay. All right, this one I don't think is on your notes, so if you'll just pay attention, you don't need to write anything down. All right, let me have Chase read it for us. Good. When it talks about the peak and the spread, you're not going to put them in the calculator. The calculator will not help you. Hallie, do you remember what you need to do first to do it by hand? What do you need to do with these numbers? Put them in order. All right? Guys, help me. Put them in order. Call them out. And what? Is that it? Okay. So I'll put them in order. Then I have to take these new numbers and add them in. Add them in. So 42 goes here. What do I want you to do with 42? Circle it. Where does 59 go? Elijah, you need to look up here, please, or you need to write it down. Those are your choices. Pay attention or write it down. All right, where does 62 go? Here, 63 here, and 65 here. Okay? All right, did it become more spread out? Yes, because I added a what? 42. That made it spread. Did it become more peaked or less peaked? More. Why? Because I added numbers in the middle. So this one is more and more. More peaked and more spread. So very similar to the other one. Okay? All right, there's your OYOs.